A basket contains 3 red balls, 5 blue balls, and 7 green balls. 2 balls are picked one after the other. That is a keyword there. One after the other. It's not as if the two are picked at once, but one after the other, without replacement. The question says find the probability that both are red. Okay, first of all, let's get the total number of balls. The total number of balls in the basket will be 3 plus 5 plus 7, which is 15. Okay, the question says the probability that both are red. For the first draw, the probability that the first draw is red will be how many red do we have? We have 3 red, so 3 over 15. Reducing the fraction, that is 1 over 5. The probability that the second draw is also red will be after drawing the first draw. Remember, we are picking the ball one after the other. The twos are not drawn at once. But yeah, we draw 2 balls, but one after the other without replacement. So for the second draw to be red, this first draw we remove 1 red already. So the total number of red now becomes, why the total number of balls becomes 14. So probability that both are red is 1 over 5 times, let me reduce this. This is 1 over 7 times 1 over 7, which is 1 over 5 times 7, 35. 1 over 35. Then that's question A. Question B, say first is blue, the other is green. Probability that first is blue is how many blue do you have? 5 blue over 15 total, which is 1 over 3. Then probability that the second, which is the other, is blue. Is it blue or green rather? The other is green. Is how many green do we have? 7. But in this first draw, we have drawn 1 ball. So the total number of one now becomes 14. So you drew 1 ball in this first draw, which is 1 over 2. Therefore, probability that first is blue, the other green is 1 over 3 times 1 over 2, which is 1 over 6. Now question C says, the probability that one is blue, the other is green. One would think that question B and question C are the same. They are not. Question B specifies that the first is blue, while the other one is green. But question C does not specify. It says one is blue, the other is green. It could be that the first is blue, the second is green, or the first is green, the second is blue. Since there is no specification of which one is blue and which one is green. You just say one is blue. It could be the first one, it could be the second one. So in that case, probability that one is blue, the other is green will be, question C, let's do it here. Probability that one is blue, the other is green is equal to probability that first is blue and second is green, or probability that first is green and second is blue. So in that case, probability that first is blue, I want to get the probability now one after the other, but first is blue is, the probability that first is blue is 5 over 15, so there are 5 blue balls there, which is 1 over 3. The probability that the second is green is, if the second is green, that will be 7 over 14. Over 14, because after drawing 1 ball here, since the 2 balls are what? One after the other, we draw only 1 here. So now say we draw the 2 at once. So after drawing 1 ball here, the total number of balls reduces to 14. That is why it is 7 over 14 here. The number of green balls still remain at 7, because in this first draw is blue ball you draw, not green ball. But the total has reduced to 14 since you draw 1 there, which is 1 over 2. Okay, this is for the first bracket. Now for this second bracket, let's do it here. Probability that first is green will be, if the first is green, that is 7 over 15. Then the probability that the second is blue will be blue. How many blue do you have? 5. But the total number of balls now becomes 14 since we have drawn 1 ball here. Therefore, the probability that one is blue, the other is green, one blue, the other green will be, now looking at this first bracket, say first blue and green, the second green, and is independent event, which is multiplication of probability, is 1 over 3. Then the probability that second is green is 1 over 2. Then or is mutually exclusive, that is addition of probability. Then first is green, probability that first is green is 7 over 15 times probability that second. So solving that, 1 times 1 is 1, and 2 times 3 is 6, plus 7 times 5 is 35. You can even reduce the fraction to make our work easier. 7 here 1, 7 here 2, 5 here 1, 5 here 3. So 1 times 1, 1, 3 times 2 is 6, 1 over 6 plus 1 over 6, which is, since the denominators are the same, we can add the numerator, 2 over 6, which is 1 over 3. Then question D say both are of different colors. Both are of different color. That is, could be that is red or green or blue. So how are we going to do that since we are drawing one ball at a time? So if I draw the first and it happened to be red, that means the second will be blue. But there are three different colors there. So how are we going to combine that? In that case, it's going to be, so both are of different color. Probability that both are of different colors. There will be probability that the first is red, the second is blue, or red and what is the other color? Green, I mean green, or blue and green. I'm just combining the three, or this is red, blue or red, or green, red, or green or blue. That is, the probability that the first is red and the second is blue, or the probability that the first is red, the second is green, or the probability that the first is blue, the second is green, or blue, red, the probability that the first is blue, the second is red, or the probability that the first is green, the second is red, or the probability that the first is green, the second is blue. So we need to take the probability of each of these one after the other. The probability that the first is red is, how many red do we have? We have 3 red, the 3 over 15, which is 1 over 5. Then probability that the second is blue. Second is blue. Where is blue? 5 blue. That is 5 over 14 since we have drawn one ball here. Okay, that is for the first group. Now let's move to the second group. The probability that the first is red is still here, which is 3 or 1 over 5. And then the probability that the second is green. Green is 7, 7 over 14, which is 1 over 2. That is for this group. Now for this other group, the probability that first is blue. How many blue? 5 over 15, which is 1 over 3. Then probability that the second is green. Green is 7 over 14 because we have drawn one here. It's 1 over 2. We are done with this. Now let's move to the second bracket. Let me use a different color there for the second bracket. Probability that the first is blue. First is blue. Where is it? Do we have any first is blue here? 5 over 15, which is 1 over 3. And probability that the second is red. Second is red. How many red do you have? 3. 3 red. But the total number of after drawing this becomes 14. That is for this now. Now let's move to this. The probability that first is green. Green, there are 7 green over 15 total. Then probability that the second is red, 3 red, but the total number of balls have decreased to 14. This is different. This one is for this first group. Now this is for this group. Then now let's do the last group. Probability that the first is green is 7 over 15. And probability that the second is blue. Blue is 5, 5. But the ball now becomes 14 after drawing this one here. So now I want to put each of these probability into this table now. Recall that all means addition of probability. But in between here is what? Multiplication. This arrow means the first is red and the second is blue. Here, the first is red and the second is green. Here, the first is blue and the second is green. So putting each of this number there, probability of different colors, therefore different colors. Okay, I'm following this now. RB, that is red, the first, then blue, the second. The probability of the first is red is 1 over, no, that's not it. Yeah, it's 1 over 5. Anyway, it's the same thing. Times plus first is red and the second is blue. Second is blue is 5 over 14. That is for this RB. Then or that is addition of probability. The first is red, the second is green. That is here. 1 over 5 times 1 over 2. Then or again. So plus the first is blue, the second is green. The first is blue is 5 over 1 over 3. 1 over 3 times the second is green is 1 over 2. Then this or here, or, so move to the second bracket now. The first is blue, the second is red. First is blue is 1 over 3 times the second is red. That is, where is red here? 3 over 14. And plus probability that the first is green, the second is red. The first is green is 7 over 15 times the second is red is 3 over 14. Then plus this last one now. The first is green, the second is blue. First is green is 7 over 15. The second is blue is 5 over 14. 5 over 14. Okay, now let's reduce anything that can reduce, yeah? This 5 can cancel out, and these 3 can cancel. 1, 2, 3 here, 1, 3 here, 5, 5 here. This is times, so the way I write it as if it's plus. This is times, please. 5 here, 1, 5 here, 3, 7 here, 1, 7 here, 2. So now, that is 1 over 14 for the first group there. 1 over 14 plus 1 times 1, 1. 5 times 2, 10, plus 1 over 6, plus 1 over 14, plus 1 over 10 again, plus 1 over 6. Now to make my calculation easier, I will bring out the one that have the same denominator together. 1 over 14 plus 1 over 14 plus 1 over 10 plus 1 over 10 plus 1 over 6 plus 1 over 6. This one is 2 over 14 plus 2 over 10 plus 1 over 2 over 6 rather, which is 1 over 7 plus 1 over 5 plus 1 over 3. LCM of 7, 5, and 3, 105. So 105 divided by 7, 15. 15 plus 105 divided by 5, 21. And 105 divided by 3, 35. Adding all of this together, 71 over 105. Where is the question? Okay, so finally, the last question he said they are of the same colors. Since we already know the probability of different colors, to get the probability of the same color will not be a problem. Remember that if the probability that an event will occur is n, then the probability that it will not occur is 1 minus n. So the probability that they are of the same color, different color rather, is 71 over 105, which we just calculated. Probability of different colors is 71 over 105. That means probability of the same color will be 1 minus 71 over 105, which is question E. Probability of the same colors is 1 minus 71 over 105. Again, let me reiterate that. We said that if the probability that an event will occur is P, the probability that it will not occur is 1 minus P. So the probability that these balls are of different color, that is question D. We have calculated that to be 71 over 105. This last one here, 71 over 105. This is our answer here. Where is it? Okay, right here. So the probability of different color is 71 over 105. That means probability of the same color will be 1 minus 71 over 105, which is 105 minus 71 over 105. And 105 minus 71, 34. So this is 34 over 105.